Hello class, today we're going to tackle section 10.8, the natural log, or you'll see it written as LN a lot of times. So, natural log is nothing special. All it really is if you have log, we've seen them all different bases, base 2, base 5, and base 10. Base 10 is called the common log. In fact, if there's nothing there, we know it to be log base 10. But if we take log to the base e, that's what we know as natural log. Okay, so e, what's e? Well, we'll get into more of that in upper division math courses. It's basically, if you take the limit as n approaches infinity of 1 plus 1 over n raised to the n power, you would find out that approaches 2.71828, and it just continues on. In fact, it's an irrational number, so it doesn't actually equal anything per se, but it does zero in right around there. And we call this number e. It's got a lot of interesting properties, which you'll get into: exponential growth and decay, continuous growth. It's what we use when we're trying to make a mathematical model of continuous growth. But anyway, not important right now. Suffice it to say that e is a number, just like pi is a number, 3.14. E is a number, and you don't even have to memorize this. Just e. E is a number. Okay, got it. All right, so let's just go from there. So log to the base e, we know is natural log, and natural log has all the same properties as regular log, in that natural log of e is equal to 1, just like log base 10 of 10 is 1, right? So I'd write this 10 raised to what power is equal, power of 1 is equal to 10. So, same way with e. Natural log of e is e raised to the power of 1 is equal to e, and I know that to be true. So, this property works just like it did with natural log. And also, there's the opposite of that, or the inverse of that. If I had e to the natural log of 1, that's going to also equal 1. So just like with regular logs, we're going to be able to use these properties to help us out a lot. So let's do some problems with natural log, which they're really nothing different than the last section. It's just that we're using natural log instead of regular log. All the properties apply. Laws of logarithms apply just like they did with regular logs. So let's take a look at some of these. Natural log of 1/3 is equal to negative 1.10. Okay, this is number 3 of your written exercises. So keep in mind, natural log is just log to the base e. So I'm looking for a number e raised to what power? Oh, negative 1.10 is equal to 1/3. So I've gone from log form to exponential form. And that's really all we have to do there. Okay? Just knowing that natural log is base e, so e raised to this power is equal to 1/3. Okay? Simple enough. Let's look at a few more of these. Let's look at something over here. Something really similar. Suppose I have e to the natural log of 5. Okay, so by the principles of logarithms, I know this to be just 5, because I know that natural log, e to the natural log of 1 is 1, e to the natural log of 5 is 5. And we can prove that with the calculator. If you take your calculator and take natural log of 5, and then take e and raise it to that power, it's like e to the 1.69 something, it'll come out to 5. Okay, so these kind of things, we can use them when trying to solve more complicated problems. And so we'll need to know how to do this. And this you already know how to do. Okay, moving on. Let's get into something fun. All right. Suppose we had, well, let me just show you that all the regular principles still apply here. Let's look at 17. So here we have natural log of 3 plus natural log of 4. So if we want to simplify that, just like before with the laws of logarithms, this would be law number 1. I could say that this is equal to natural log of 3 times 4, or natural log of 12. So the laws of logarithms still apply. Nothing new there. Just get used to writing natural log instead of log when we're using them. Okay, something fun. Oh, here we go. Number 27. Natural log x squared is equal to 9. Okay, so I'm thinking by the properties of logarithms, I can take that exponent up there and bring it out front. That'll give me 2. Natural log x is equal to 9. Okay, divide both sides by 2. Natural log x is equal to 9/2. Okay, so now let's go into exponential form and we can solve this thing without a calculator. So I'm going to have e to the 9/2 is equal to x. Boom, done. Solve it for x. So there you have it. Same laws of logarithms, same properties, and it still works. Okay? And that's about it. We'll get into, we'll work a few more of these just for fun, and then I'll post on your assignment, I'll post some worked out examples. A lot of these you'll see worked out already. All right, let's take a look at number 39. 39 gives us natural log x is equal to 0. Okay, so I've got natural log of a natural log. So first off, let's look at this. Let's write it into exponential form. All right, remember natural log is log base e. So I'm going to have e raised to the power of 0 is equal to natural log x. Okay, so anything raised to the 0 power I know to be 1. So 1 is equal to natural log of x. So let's put this into exponential form. So I have e to the 1 is equal to x. Okay, so now I can see that x is equal to e. There you have it. There's number 39. All right, so most of these are just like we've been doing, except we're doing it with natural log instead of log base 10, which is a common log. And other than that, all the principles apply, the laws of logarithms apply. And so just have out these problems here in 10-8, and you shouldn't have any trouble with those. If you do, refer to some of these example problems I've worked out for you. All right, there you have it. Good day.